Hello everyone, welcome to Spectrum Education. I'm going to explain about electronics, which is a part of physics 10th class, chapter 12. Earlier, we learned about introduction of electronics, right? Yes. Today, understanding resistance and voltage. Today, you are all be able to explain the relationship between current, voltage, and resistance through Ohm's law and use Ohm's law to calculate the current, voltage, and resistance. Yes, coming to voltage. Voltage is the pressure or push behind the flow of current. It is also referred to as potential difference. A voltmeter is used to measure voltage. It is placed parallel to the components to measure the voltage in the circuit. Next, resistance. Resistance is a measure of how much a material opposes the flow of electric current going through it. The greater resistance, the more energy is needed to push the current through the component, which can affect the overall performance of electrical circuits. An ohm meter, this is ohm meter, is used to measure the amount of resistance present when a current is passed through a particular component. Yes, coming to most important law, Ohm's law. What Ohm's law states that? Ohm's law states that the current through a conductor is directly proportional to the potential difference across it, provided the temperature remains constant. The formula current is equal to voltage by resistance. Next, here is the example Ohm's law. Calculate the voltage or potential difference. Both are same voltage or potential difference through a resistor with a resistance of 40 ohms with a current of 0.6 amperes flowing through it. Here are the steps to follow. First step, what are the given and missing values? Here, given values current and resistance. Missing values voltage. Now we have to find out the voltage. What is the relationship between current, resistance and voltage from Ohm's law? Current is equal to voltage by resistance. Now, voltage is equal to current into resistance. Current 0.6, resistance 40. 0.6 into 40 becomes 24 volts. The voltage 24 volts. Answer is 24 volts. Next, another example. If the current is increased from 0.6 amperes to 2.2 amperes while maintaining the same voltage of 24 volts, what will be the new resistance required? First step, given values and missing values. What are the given values? Current and voltage are the given values. Resistance is the missing value. Next, formula from Ohm's law. Current is equal to voltage by resistance. Now we have to find resistance. Resistance omega is equal to, ohms is equal to V by I. V 24, I 2.2. 24 by 2.2, 10.9 ohms. The answer is resistance 10.9. Next, factors. Resistance of a uniform metallic conductor is directly proportional to length of the conductor, inversely proportional to area of cross section, directly proportional to the temperature, and it depends on the mostly nature of the material. Next, resistivity. Okay, it is defined as the resistance offered by a cube of material of side 1 meter when current flows perpendicular to its opposite faces. Its SI unit is ohm meter. Next, factors. Resistivity does not change with the change in length or area of cross section, but it changes with change in temperature. Resistance depends on length, area of cross section and temperature, but resistivity does not change with change in length or area of cross section. It changes with change in temperature. Metals and alloys resistivity range is 10 power minus 8 to 10 power minus 6 ohm meter. Insulators resistivity range is 10 power 12 to 10 power 17 ohm meters. Okay. Generally, copper and aluminum are used for electrical transmission lines as they have lower resistivity. Yes, summary. What is the voltage, ma? Voltage is the pressure or push behind the flow of current. It is measured in volts using voltmeter. Voltage is also referred as potential difference. Next, resistance. It opposes current flow and is measured in ohms. It can be calculated by dividing the voltage by the current.